Prologue. At the turn of eras. The end of the 19th century was a time of great naval ambition and complex geopolitical challenges for Russia. After the humiliating outcomes of the Congress of Berlin in 1878, which stripped the Russian Empire of the fruits of victory in the Russo-Turkish War, and against the backdrop of the rapid growth of the German fleet, the country keenly felt the need to create a modern navy. In August 1881, under the chairmanship of General Admiral Grand Duke Alexei Alexandrovich, a special conference convened in St. Petersburg by decree of Emperor Alexander III. The ministers heading the War, Navy, and Foreign Affairs ministries faced an extremely complex task to define the foundations of Russia's naval policy and a shipbuilding program for the next 20 years. On August 24, 1881, the conference concluded its work. The main conclusion was formulated with utmost clarity, quote, 0. For the naval forces of the Baltic Sea, the primary task was, quote, 1. Based on these strategic guidelines, the shipbuilding program developed by the special conference provided for the construction of 16 new ironclads for the Baltic Sea over 20 years. The strongest ships of the German fleet at that time were the casemate ironclads of the Saxon class, displacing 7,400 tons, with a speed of about 14 knots, armed with 6 260mm guns. Therefore, the conference deemed it possible to limit the displacement of the planned ironclads to 8,400 tons, arming them with 300 5mm guns. In accordance with these requirements, the first two ships of the program, Imperator Alexander II and Imperator Nikolai I, were already under construction. But the world did not stand still, and in January 1888, design work began on the third ironclad of the 1881 program, a ship destined to become the Navarin. Chapter 1. The birth of a project. The design of the new ship was carried out simultaneously in several quarters. The Naval Technical Committee, MTC, the renowned naval architect E.N. Gulyayev, and the Society of Franco-Russian Works. The manager of the Naval Ministry, Adjutant General I.A. Shestakov, put forward rather stringent requirements. The new ship, while retaining the armament of Imperator Alexander II, was to have quote, _2, a speed of 14 knots and a cruising range of 500 miles were permissible. The first project ready was that of the Society of Franco-Russian Works. The Society's chief representative, P.K. Dubois, presented it to I.A. Shestakov as early as February 11, 1888. The ironclad project, with a displacement of 6,431 tons, seemed to satisfy all the ministry's requirements. On May 21st, the Naval Technical Committee reviewed the drawings and calculations presented in 3 variants. As Alexander II and Nikolai I served as the prototype in all cases, the projects turned out to be very similar. 4 days later, the General Admiral approved them with minor changes. It seemed that all that remained was to choose the best option and commence construction. But fate decreed otherwise. Unexpectedly, the main naval staff received information about the design of new ironclads in Germany, of the Worth class, armed with 6 280mm guns, with a displacement of over 10,000 tons and a speed of 16 knots. These ships would surpass any Russian ironclad in strength. Urgent countermeasures were required. P.K. Dubois, an enterprising and far-sighted man, realized that the Society of Franco-Russian Works had an opportunity to secure a large, lucrative order. The project simply needed to be revised quickly. The Society's engineers worked diligently, and exactly 4 months later, Dubois submitted the drawings for the new ship to the MTC. By increasing the ironclad's length by 20 meters, beam by 2 meters, and displacement by 2,500 tons, P.A. Titov, who led the project development, provided for sufficiently powerful armament: 4 305mm guns in 2 armored turrets and 4 152mm guns in a casemate. The armor belt, 406mm thick, tapered towards the ends to 203mm. The speed was 16 knots, and with forced draft, up to 17 knots. The MTC, having reviewed the project on October 13th, recommended strengthening the medium-caliber artillery and increasing the thickness of the side, traverse, and casemate armor. After modifications, the number of 152mm guns doubled. The armor of the traverses and casemate reached 254 to 305mm, and the displacement increased by another 500 tons. However, despite the obvious need to build the new ironclad, the MTC remained indecisive. Whether to award the contract for such a large ship to a private firm, buy the project and build the ship at a state-owned shipyard, or, without further ado, revert to the proven design of Imperator Nikolai I. After all, the new German ironclads had not yet been laid down, and who knew how it would all end? It was only after P.K. Dubois managed to obtain permission from Emperor Alexander III himself to sign a contract for the construction of an quote, _3 that the MTC was forced to approve the project. Red tape continued for about another 3 weeks. And only on April 12, 1889, did the acting chief of the main directorate of shipbuilding and supplies, Rear Admiral V. Werner Popov, and the chief representative of the Society of Franco-Russian Works, P.K. Dubois, sign the contract for the construction of the new ironclad. According to the contract, the Society of Franco-Russian Works undertook to build a steel hull for an ironclad of 9,476 tons, with final outfitting and complete preparation for service. The vessel was to be built on a part of Galerny Island in St. Petersburg, temporarily transferred for the Society's use from the best Siemens Martin Russian steel according to the drawings and specifications. The total amount payable under the contract was 2,900,000 rubles, to be paid in 20 installments as work progressed. The launch of the ship was planned for July 1891, and delivery to the Treasury was scheduled for August of the following year, 1892. Chapter 2. Laying Down and Construction. On July 1, 1889, work began on the construction of the ironclad on the slipway of Galerny Island, leased at that time by the Society of Franco-Russian Works. On August 19th, the ship received the name Navarin, in honor of the famous Battle of Navarino in 1827, where the combined Russian-Anglo-French squadron under the command of Admiral L.P. Hayden won a brilliant victory over the Turkish-Egyptian fleet. The formal keel-laying ceremony took place almost a year later, on May 19, 1890, in the presence of Emperor Alexander III. It was a significant event in the life of the Russian fleet. Not just another ship was being laid down, but Russia's first ironclad of classic design, with 4 main-caliber guns in 2 turrets at the ends and a battery of guns amidships. A sad rule in the construction of ships for the Russian fleet was the introduction of alterations and corrections during the building process. The Navarin did not escape this fate. As early as September 21st, 1889, the manager of the Naval Ministry, N.M. Chikachev, ordered that on all ships, starting with the ironclad Navarin, 305mm guns with a barrel length of 35 calibers be installed instead of the previously planned 30-caliber ones. A caveat was added, however, quote 6, allowing for the possibility of refusing to install the new guns, but the Society's directorate, understanding the importance of enhancing the ship's firepower, decided to undertake the necessary modifications. The revision of the drawings, was completed by the end of January 1890. Work at the shipyard proceeded routinely. By July 19, 1890, over 2,500 tons of steel had already been placed on the slipway. There were practically no delays. Although on September 24th, the MTC presented another Quote 7, ordering that the side of the casemate, Quote 8, and that the ports of 4 152mm guns be moved to the corners of the casemate to enhance longitudinal fire. Redrawing had just begun when N.M. Chikachev ordered that the corner casemates not be made. A similar story occurred with the Navarin's masts and yards. The original design had one mast. In November 1889, N.M. Chikachev ordered the installation of 2 masts, but in September of the following year, he approved a variant providing for only the mainmast. All this, of course, hindered the normal progress of work, but the main difficulties lay ahead. Chapter 3. Problems with armor and machinery. A bottleneck in the ship's construction turned out to be the delivery of armor, ordered from the Izhora works. They were required to manufacture 125 plates, not including turret armor, ranging in thickness from 51 to 406 millimeters. The Izhora works, being the primary supplier of armor for the entire Russian fleet, was clearly unable, given its production capacity, to satisfy all customers. The blame for this situation lay with the Naval Ministry, which, while developing the shipbuilding program, had failed to arrange either for the necessary quantity of armor to be produced at state-owned plants or for contracts to be concluded with private subcontractors in a timely manner. The fact that many difficulties would arise with armor deliveries became evident by the end of 1890. Frantic attempts by the acting commander of the St. Petersburg port, Rear Admiral V.P. Verkhovsky, to rectify the situation succeeded in only one instance. On January 9, 1891, an order for armor deck plates was placed with the Nevsky Works. The main problem, however, remained the delivery of armor for the belt below the waterline. Its absence delayed the launch of the otherwise nearly completed ship. By the end of June, it became clear that the contract deadline could not be met. Having reviewed the situation, the acting manager of the Naval Ministry, Adjutant General O.K. Creamer, expressed the hope to the Society's management that the launch could take place no later than August 15th. But 3 weeks later, the port's chief naval engineer, A.A. Greknev, reported that even with the most effective measures, Navarin could not be launched before August 30th. But this date also proved unrealistic. The installation of armor plates below the waterline was only completed at the very end of September. By this time, a commission appointed by V.P. Verkhovsky had inspected the hull and launching apparatus. Most compartments were tested for water tightness. Parallel to the armor problems, difficulties also arose with the machinery. By mid-1891, a tense situation developed at the nearby works of the Franco-Russian Society. Work on the Navarin's engines was underway there. The contract, signed on October 11, 1889, stipulated the manufacture of 2 triple-expansion steam engines with a total power of 9,000 horsepower, 14 boilers, stern tubes, shafts, and propellers. Work proceeded quite successfully until May 1891, when the time came to test the first 4 boilers at their design pressure. It ended in complete failure, and an analysis of what happened revealed serious manufacturing defects. Chapter 4. The Launch. Finally, on October 8, 1891, the anniversary of the Battle of Navarino, the long-awaited launch of the ironclad Navarin took place in St. Petersburg. The ceremony was held at the Galerny Island shipyard of the Society of Franco-Russian Works, under the direction of P.A. Titov, who supervised the construction. It was an impressive moment. The huge steel hull, over 100 meters long, slowly slid down the slipway into the waters of the Neva. The ship had a distinctive appearance, 4 funnels arranged in a square, which made it unique among Russian ironclads and earned it the nickname taburetka, the stool. The absence of a proper foremast, replaced by a thin antenna mast, also gave the ship an unusual silhouette. The technical characteristics of the Navarin were impressive for their time. Displacement, design, 9,476 tons, actual, 10,206 tons, length, 105.9 meters, at waterline. Beam, 20.4 meters, draft, 8.4 meters. Armor, waterline belt, 406 to 305 millimeters, upper belt, 305 millimeters, casemate, 127 to 152 millimeters, deck, 51 to 76 millimeters, turrets, 305 millimeters, conning tower, 254 millimeters engines, 2 vertical triple expansion steam engines, 12 cylindrical boilers, power, 9,144 horsepower, speed, 15.85 knots. Crew, 26 officers and 596 sailors. Armament, 4 times 305 mm 35 guns, 8 times 152 mm 35 guns, 14 times 47 mm guns, 12 times 37 mm guns, 2 times 63.5 mm landing guns, 6 times 381 mm torpedo tubes. The Navarin became the first Russian ironclad to have the classic armament of 4 heavy, 305 mm main caliber guns in 2 turrets, fore and aft, and a battery of medium, 152 mm caliber guns in the central part. It was the 4th ironclad built for the Baltic Fleet under the 20-year program adopted in 1881, and the first whose design from the outset included the capability for long ocean voyages, including to the Far East. Chapter 5. The long outfitting. After the launch, a long period of outfitting began, stretching over almost 5 years. This was typical of Russian shipbuilding at the time. Many ships spent longer on fitting out than on the slipway. During the winter of 1891 to 1892, work practically ceased due to severe frosts. Only in the spring of 1892 could equipment installation resume. However, supply problems continued. The situation with turret armor proved particularly difficult. 4 plates with embrasures for the main caliber turrets had to be ordered from France, from the Saint-Chamond works, as the Izhora works could not cope with the orders. On June 14, 1894, the Navarin's engines were tested at their moorings, and on June 27th, the ironclad began its second commission. Although construction work was still not fully completed, part of the armor and artillery were missing. In the autumn of 1893, the Navarin was moved to Kronstadt to complete the work. Here, fitting out work, installation of armament and equipment continued. During the winter of 1895 to 1896, the ship received its conning tower armor. The frame of the conning tower itself was only assembled in November during trials. The booms and rigging for anti-torpedo nets, platforms for searchlights, and armor plates on the turret frames. In February 1896, 4 37mm Hotchkiss guns and 2 Baranovsky landing guns from the deck pedestals were removed from the ship, replaced by 6 47mm single-barreled guns. Before the start of the campaign, the metallurgical works delivered the artillery Quote 12, and the Kronstadt port installed the booms and anti-torpedo netting that had been removed for the winter. At the same time, the ship was equipped with a rudder position indicator, Lieutenant Kolbasiev's system, 2 electric winches, and electric signal lanterns, Lieutenant Colonel Tabulevich's system, that had recently appeared in the fleet. In the spring of 1896, the Navarin was moved to Reval, Tallinn port, where work continued for another 2 months. The ship finally entered service only in June 1896, almost 7 years after construction began and 5 years after its launch. Chapter 6. Design Features. The Navarin was a ship unique for the Russian fleet, whose design combined both advanced solutions and some outdated elements. Hull and armor. The ship's hull was assembled from 93 frames, frame spacing 1.2 meters, and had 6 stringers on each side, one of which also served as a shelf for the armor. A double bottom was provided between frames 20 and 76, and 2 longitudinal bulkheads were located between frames 31 and 65. These, along with 9 transverse bulkheads, divided the hull into numerous watertight compartments. To reduce rolling, 2 bilge keels, each about 60 meters long, were installed. The ironclad was armored according to the all-or-nothing principle. The waterline belt, 69.5 meters long, consisted of 19 steel iron plates on each side, 2.2 meters high and 3 to 4 meters long. The plates in the central part were 406 millimeters thick, thinning to 356 millimeters and 305 millimeters towards the ends. At the ends, the belt was closed off by 305 millimeters thick transverse bulkheads, traverses. Above the waterline belt was the lower casemate or upper belt, 49.3 meters long, consisting for each side of 10 steel iron plates 2.4 meters high, 3.3 to 4.2 meters long, and 305 millimeters thick. Higher still on the upper deck was the upper casemate, which protected the battery of 152 millimeter guns around its entire perimeter and consisted of 127 millimeter steel iron plates. The guns were separated from each other by 25.4 millimeters thick splinter shield/protection bulkheads. A carapace armored deck protected the ship outside the waterline belt. It started from the traverses and ran to the stem and stern post. The thickness of its horizontal part was 50.8 millimeters, and the slopes were 76 millimeters thick. Each turret was protected by 12 305 millimeter steel nickel plates and a slightly convex 50.8 millimeter roof. The conning tower consisted of 4 curved 254 millimeter steel iron plates and one 152 millimeter plate protecting the narrow entrance. The mushroom-shaped roof was 50.8 millimeters thick. In total, the vertical protection included 138 steel iron and 24 steel nickel plates laid on a wooden backing of larch. Its thickness roughly corresponded to the thickness of the plates themselves and secured with 736 bolts. According to the design, the total weight of the armor was 2,807 tons, 29.3% of displacement. Artillery armament. The main caliber consisted of 4 305 mm 35 caliber guns manufactured by the Obukhov Works, mounted in 2 turrets with an external diameter of 7.71 meters and a height of 5.49 meters from the lower base of the turret race to the roof. The gap between the rotating part of the turrets and the deck was covered with a rubber mammering, weather seal, to protect against spray. The total mass of the turret was 169,041 kilograms. Turret rotation and vertical aiming of the guns, as well as other operations, were performed using hydraulics. The vertical aiming angles ranged from -5 degrees to +15 degrees, and the horizontal aiming angles were 243 degrees for the bow turret and 214 degrees for the stern turret. The horizontal traverse speed for the bow turret reached 4.6 degrees per second, and for the stern turret, 3.5 degrees per second. The theoretical rate of fire was 1 shot per 2 minutes 22 seconds. The medium caliber was represented by 8 152 mm 35 caliber guns, manufactured by the Obukhov Works, mounted in the casemate. They were installed on Vavassar-Dubrov side-mounted carriages. In the stowed position, the guns were fully retracted inside the battery, and the gun ports, 1.1 meters wide, were tightly sealed. Anti-torpedo boat artillery included 14 47mm and 12 37mm single-barreled Hotchkiss guns. 8 47mm guns stood behind the high bulwark on the upper deck, and another 6 were on the bridges. All 37mm guns were placed on the fighting top. Traditionally, the artillery armament was supplemented by 2 63.5mm Baranovsky landing guns. Mine and torpedo armament. The ironclad had 6 381mm above-water torpedo tubes. The bow traversing tube, passing through the stem and situated 2.43 meters above the water, could be trained within 10 degrees. 4 side tubes were 1.82 meters above the water and protected by the 305mm armor of the upper belt. The stern torpedo tube, installed in the stern post, was fixed. The ammunition load consisted of 12 19-foot self-propelled Whitehead mines, torpedoes, of the 1889 model. To arm the steam cutters, 3 removable launchers for throwing mines were provided. Additionally, the cutters could be armed with spar torpedoes. Power plant. The Navarin had 2 3-cylinder triple-expansion steam engines. The diameters of the high-pressure, intermediate pressure, and low-pressure cylinders were 1,030 millimeters, 1,500 millimeters, and 2,190 millimeters, respectively, with a piston stroke of 1,067 millimeters. When cruising at economical speed, it was possible to disconnect one cylinder, reducing coal consumption. The engines were designed for a working steam pressure of 9.4 atmospheres and a maximum rotational speed of 100 revolutions per minute. Both engines weighed 354 tons. Steam was generated in 12 cylindrical 3-furnace fire tube boilers, 4.8 meters in diameter and 2.1 meters long, installed in 4 boiler rooms, 2 forward and 2 aft on the port and starboard sides. Each boiler room had its own funnel, giving the Navarin a most unusual appearance for a warship. The maximum steam pressure in the boilers could reach 14.6 atmospheres. The boiler shells were made of steel from 15 to 28.5 millimeters thick and covered with a special insulating compound, over which they were sheathed with a casing of galvanized iron 1.58 millimeters thick. The total grate area was 82.3 square meters, and the heating surface was 216 square meters. The weight of the boiler plant with foundations was 415 tons, and the weight of water in the boilers was 205 tons. The propellers, with a diameter of 5,334 millimeters, were made of phosphor bronze. Chapter 7. First Years of Service. After entering service in June 1896, the Navarin was assigned to the Baltic Fleet. However, its service in the Baltic was short-lived. Soon the ship was assigned to the Mediterranean Sea. The international situation in the Mediterranean at that time was tense. Relations between Turkey and Greece deteriorated, and a conflict arose in Cyprus. The Russian government decided to send a squadron to the region to protect Russia's interests and its citizens. The Navarin became the flagship of the Russian squadron in the Mediterranean. Its presence in the region held significant political importance. Russia was demonstrating its ability to operate in distant maritime theaters. Service in the Mediterranean became a good school for the Navarin's crew. The ship made long voyages, visited various ports, and participated in exercises and maneuvers. The crew gained valuable experience in operating the ship under conditions approaching combat. However, some of the ship's shortcomings became apparent even then. The Navarin's low freeboard made it not very suitable for navigating the open sea in stormy weather. The ship was heavily shipped by waves, causing discomfort for the crew and limiting the use of the artillery. Nevertheless, the Navarin successfully fulfilled its tasks. Its presence in the Mediterranean contributed to the settlement of the Turkish-Greek conflict and strengthened Russia's position in the region. Chapter 8. To the Far East. In 1898, the fate of the Navarin took another turn. The deteriorating situation in the Far East, where Japan was rapidly gaining strength, demanded the strengthening of Russia's military presence in the region. On March 16, 1898, the Navarin arrived in Port Arthur and became the flagship of the Pacific Squadron. This was a time when Russia had just leased Port Arthur and was beginning to establish its naval base there. The arrival of the Navarin in the Far East coincided with important political events. Russia was actively strengthening its position in Manchuria and Korea, causing serious concern in Japan. The presence in Port Arthur of such a powerful ship as the Navarin became an important factor in deterring Japanese expansion. For most of 1898 to 1899, the Navarin served as a station ship in Port Arthur, occasionally making short trips to Vladivostok, Japanese, Korean, and Chinese ports. The ship participated in diplomatic missions, showed the flag, and conducted exercises. In 1900, the Navarin took an active part in suppressing the Boxer Rebellion in China. The ironclad was anchored off the Taku forts, and its landing company fought ashore. This was the ship's baptism of fire, albeit in the context of a colonial war. Participation in combat operations revealed both the strengths and weaknesses of the ship. On one hand, the powerful armament and solid armor made the Navarin a formidable opponent. On the other hand, the technical obsolescence of some systems was beginning to show, especially compared to the newest Japanese ships. Chapter 9. Return to the Baltic. By 1902. It became clear that the Navarin needed serious repairs and modernization. 5 years of service in a tropical climate and intensive use had taken their toll. Furthermore, technological progress had not stood still, and the ship was beginning to age. On April 22, 1902, the ironclad returned from the Pacific Ocean, dropped anchor in Libau, now Liepāja, Latvia, and a routine inspection was carried out immediately. The commission found that the ship's machinery had no serious defects, and the boilers, after replacing some tubes and caulking, could be operated for another 5 years. After the inspection, the ship was assigned to the Training Artillery Detachment, and the Navarin spent the winter in Libau. Here, a number of modernization works were carried out on the ship. The boilers were reinforced, the heavy foremast was removed and replaced with a thin antenna mast, and new equipment was installed. The ship's condition was generally good, indicating the high quality of its construction and proper operation. However, time was relentless. The Navarin could no longer be considered a modern ship compared to the latest Japanese ironclads, armed with quick-firing artillery and possessing more advanced fire control systems. Nevertheless, when the Russo-Japanese War began in 1904, the Navarin was included in the 2nd Pacific Squadron, which was being formed to reinforce the Russian fleet in the Far East. Chapter 10. In the 2nd Pacific Squadron. The formation of the 2nd Pacific Squadron under the command of Vice Admiral Z.P. Rozhestvensky was a desperate attempt by Russia to turn the tide of the war at sea. After the loss of the 1st Pacific Squadron in Port Arthur and the demise of its best ships, the country threw into battle everything it could. The Navarin became part of the 5th Division of the squadron. Despite its age, the ship was already 13 years old, it still remained a powerful fighting unit. Before being dispatched to the Far East, additional work was carried out on the ironclad. 2 47mm guns were moved to the turret roofs, used to save ammunition during main-caliber gunnery training. Another 2 were removed entirely, and 4 75mm Canet guns were installed in their place. On October 2, 1904, the Navarin sailed from Libau as part of the 5th Division of the 2nd Pacific Squadron. Thus began one of the most dramatic voyages in the history of the Russian fleet, the passage from the Baltic Sea to the Far East around Africa. The journey was long and arduous. The squadron crossed the North Sea, the Atlantic Ocean, rounded Africa, and traversed the Indian Ocean. Over 7 months of sailing, the ships covered more than 18,000 miles. For the Navarin, no longer a young ship, this passage was a severe trial. Throughout the voyage, technical problems constantly arose. The old boilers and machinery required constant attention. Coal was in short supply, necessitating numerous stops for bunkering. The crew was exhausted by the long voyage under harsh conditions. Nevertheless, the Navarin reached its destination. On May 14, 1905, Rozhestvensky's squadron entered the Korea Strait, where the Japanese fleet under Admiral Togo was already waiting. Chapter 11. The Battle of Tsushima. On May 14, 1905, the Battle of Tsushima began, one of the most tragic in the history of the Russian fleet. For the Navarin, this day was the last. During the daytime battle on May 14th, the ironclad Navarin sustained serious damage. 6 shells hit the ship, inflicting mortal wounds. Among the dead were the ship's captain, first rank Baron B. Fittengoff, and 17 other crew members. Despite the damage, the Navarin continued to fight. By evening, it was one of the few ships whose searchlights were still fully operational. The commander ordered the sea to be illuminated to prevent surprise attacks by enemy destroyers. This decision, although tactically sound, made the ship a prime target for Japanese destroyers. Due to an engine breakdown, the Navarin lagged behind the rest of the squadron. At night, it became easy prey for Japanese destroyers, which attacked the straggling and damaged Russian ships. Around 2200 on May 14th, the first Japanese torpedo struck the aft part of the ironclad's port side, causing significant damage. The ship began to sink, settling by the stern as far as the turret. Alarm was sounded, and crew members took their stations. To evade enemy attacks, the ironclad headed towards the Korean coast, making 4 knots speed. Artillerymen fired blindly from their guns. Japanese destroyers approached, surrounding the Navarin. They launched torpedoes and fired guns and rifles. Then a second torpedo hit the middle of the ironclad's starboard side. The ship continued to list to starboard. Panic reigned on board. Part of the crew began preparing boats for launching, but someone in haste cut the tackles holding a cutter, and it fell into the sea and sank. Another launched boat was overcrowded and also sank under the weight of the people. At that moment, an enemy destroyer approached the port side of the sinking Navarin and fired a 3rd torpedo. An explosion occurred, its flash blinding those in the water. A column of water rose higher than the ironclad's masts. The Navarin capsized, its deck covering 2 boats full of people, and then sank. Those not trapped by the ironclad or caught in the whirlpool formed at the site of the sinking, found themselves in the water, and tried to save themselves using floating logs, boards, and wooden crates, which the waves tossed about, injuring people in the darkness of the night. Of the 700 crew members, only 30 survived. According to other sources, only 3 men survived. The exact number of survivors remains a subject of debate among historians. Chapter 12. Circumstances of the sinking. The circumstances of the Navarin sinking still cause debate among historians. There are several versions of how exactly the ship was lost. According to official Japanese reports, the Navarin fell victim to destroyer attacks. Japanese sailors claimed they had placed bundles of floating mines connected by cables in the ship's path, into which the ironclad drove. According to the accounts of surviving Russian sailors, the Navarin was riddled with torpedoes from destroyers. The ship, lagging behind the squadron due to damage and engine failure, became an easy target for Japanese destroyers, which attacked it from all sides. Some historians suggest that the cause of the sinking could have been the ship's own mines, which might have detonated upon torpedo impact. The Navarin was carrying a full combat load, including torpedoes and shells. A torpedo hit could have triggered a chain reaction of explosions. There is also a version that the ship might have struck mines that the Japanese could have laid in the path of the retreating squadron. Regardless, the fact remains: the Navarin, one of the most powerful ironclads of the Russian fleet, was lost in the night of May 14th to 15th, 1905, in the Korea Strait. Its sinking became a symbol of the tragedy of Tsushima and of the entire Russian fleet in the Russo-Japanese War. Chapter 13. Historical Assessment. The Navarin holds a special place in the history of the Russian Imperial Navy. It was Russia's first ironclad of classic design, with 4 main-caliber guns in 2 turrets at the ends and a battery of guns amidships. It became a model for all subsequent ships of this class. From a technical standpoint, the Navarin was an advanced ship for its time. Its armor, armament, and sea-keeping qualities matched the best world standards of the late 1880s. The ship was designed for long ocean voyages, a new concept in Russian shipbuilding. However, the Navarin also had serious shortcomings. Its low freeboard made it poorly suited for navigating the open sea in stormy weather. The square arrangement of its 4 funnels was not optimal aerodynamically or for maintenance. Some systems, particularly the hydraulic turret drives, were complex and unreliable. The main problem for the Navarin, as for many other Russian ships of that time, was the lengthy construction period. During the 7 years from the start of construction to commissioning, the world level of shipbuilding advanced significantly. By the time it entered service, the Navarin was no longer a modern ship. Nevertheless, the Navarin played an important role in the history of the Russian fleet. Its service in the Mediterranean and the Far East demonstrated that Russia was capable of operating in distant maritime theaters. The ship's participation in suppressing the Boxer Rebellion showcased its combat capabilities. The sinking of the Navarin in the Battle of Tsushima became a symbol of the tragedy of the Russian fleet in the Russo-Japanese War. A ship built with such effort and hope was lost in its first serious battle, taking with it the lives of almost its entire crew. Chapter 14. The Legacy of Navarin. Despite its tragic end, the Navarin left a significant mark on the history of Russian shipbuilding. The experience gained in the design and construction of this ship was used in the creation of subsequent Russian ironclads. Design solutions tested on the Navarin found application on the ironclads of the Poltava class, the Retvizan, the Cesarevich, and finally, on the famous Borodino class ironclads. Many elements, the arrangement of artillery, the armor system, the general layout, became classic in Russian shipbuilding. The name Navarin continued to live on in the Russian fleet. After the sinking of the ironclad, the name was given to a battle cruiser laid down in 1915, but never completed due to the Revolution and Civil War. Later, a diesel-electric ship of the Amguema type, 1967 to 1999, a sister ship and companion of the Aube in delivering Antarctic expeditions, bore the name Navarin. Currently, the name is carried by a tug pusher built in 1989, operating in Novorossiysk. The memory of the ironclad Navarin is preserved in historical works, museum exhibits, and ship models. The Central Naval Museum in St. Petersburg houses a highly detailed model of the ironclad. Drawings and diagrams of the ship are published in specialized publications such as the magazine, quote, 17. The story of the Navarin is not just the story of a single ship, but of an entire era in the development of the Russian fleet. It is a story of hopes and disappointments, technical achievements and human tragedies, courage and self-sacrifice. Epilogue. Lessons of history. The ironclad Navarin became a symbol of an entire era in the history of the Russian fleet, an era of great hopes and bitter disappointments. Its fate reflected all the problems and contradictions of Russian shipbuilding in the late 19th and early 20th centuries. On one hand, the Navarin demonstrated Russia's ability to create modern warships comparable to the best world standards. On the other hand, lengthy construction times, bureaucratic red tape, and constant project alterations negated these achievements. The service of the Navarin showed that the Russian fleet could operate in distant maritime theaters, protecting the country's interests far from its own shores. But the loss of the ship in the Battle of Tsushima was a bitter lesson, demonstrating that technical perfection alone is insufficient. Sound tactics, well-trained crews, and an effective command system are also necessary.